Okay, so we're going to wrap up our discussion of complex numbers.
Wait, are we going to take a quiz on this sometime next week?
I'm not sure when, but yes, we'll be quizzed on this at some point. I would recommend it, yes. All right, so we're going to be wrapping up chapter 4 by talking about how to solve quadratic equations. Now, we've already talked about solving quadratic equations before the break. The difference, however, is before the break, when we worked with quadratic equations, when we got a negative square root as our answer, we eliminated it because we were only dealing in real numbers. Now, that's not a problem because if we get a negative square root, we know what to do. And one thing I want you to be aware of is notice what the topic is. The topic is finding imaginary solutions, plural. Here's my question. If I didn't tell you that there was going to be more than one answer, how would you be able to tell anyway? What in the problem tells you that there's going to be more than one answer? Which number 2? The big one or the little one? The little one. We call that little 2 and
Square.
well, we call it an exponent, but yes, we call it a square. The fact that we have a square tells us that there's going to be 2 answers. Just like if I ask you for the square root of 25. What is the square root of 25? It is. It's 5
And negative
times 5.
Yeah, it's
That's
also
right.
negative five.
It's also negative 5 times negative 5. So there's 2 answers. Now, we usually just deal with the positive one, and in fact, that one is called the principal solution. Principal as in same spelling as Dr. Shelley, principal of the school. But there is a second solution. There is a negative solution as well. So when we get down to the answers here, that's going to be our answer. We're going to have a plus answer, and we're going to have a minus answer. Now, other than that little wrinkle, solving these equations is the same as solving equations for x that we've been doing since pre-algebra. What's the first step in solving this equation? Or more accurately, what's our goal? What are we trying to do here?
Simplify it.
What are we trying to do here? Solve it by doing what?
Simplify.
Simplifying it by doing what?
Finding x.
Finding x. And we're going to find x. Where is x going to be when we're done? Yes. But where in the problem? Is it going to be with other things?
It's going to have an exponent after it.
Is x going to be with other things?
No, it's going to be by itself.
It's going to be by itself. So our goal is to isolate the variable. Treat it like it's got leprosy. So the first thing we're going to do is what?
Minus 32.
We're going to subtract 32 from both sides. You probably don't even need me to have this on the board in order for you to solve this. I bet you all could solve it. If I just said solve for x, you don't know what to do. I have faith.
Good.
Call me a cockeyed optimist, but I have faith that you could all solve this for x. What?
What's a cockeye activist?
Just phrase.
Saying.
Okay, what's the next step?
Divide by 2.
Divide both sides by 2. You're not taking notes. Pause. What? Start late. Better late than never. Now, Can anybody tell me when I have a square, if I have x squared, what am I going to do to both sides to find x?
Square root.
Square root it.
No, I need you.
I'm going to take the square root. So I take the square root of both sides.
It's alright.
Notice what happens on the right side of the equal sign. I have plus or minus. This is a small but important detail on a quiz, in a problem. Because we have a square, we know we're going to have two answers, a positive answer and a negative answer. Now, prior to this week, if we saw this, we would be like, what? Negative 16? I don't know the square root of negative 16. I'll just guess 4. Which we all know is not right. But now we do. Now we know, please, in the back, unless you already know how to do this and you'd like to come up and finish. Either one of you. Okay, then please, let me talk. You can talk when I finish. We know the square root of negative 16 is what?
4i.
4i. So our answer is plus or minus 4i. What would you all do today without Jillian? Why don't you give her a big thank you? Down, you got it down.
I will be answering.
I'm gonna have to go back to the popsicle sticks. Yeah, I do.
I know.
That one same person answering. I want different people answering.
Show us if you will be answering.
Thanks. I know. I don't know.
All right. I was very pleased to see that. In fact, I didn't see anybody who didn't get this one. But I saw that many of you also tried number 2, which I am pleased to see. However, you all didn't follow that chart. And I'll show you what I mean in a second. We can all agree that the first step is to subtract 15 from both sides. And that the next step is to take the square root of both sides. What I want to do is I want to go back to that chart. Remember the number question is 15. Go back to this chart. Ask yourself a question. Can you factor 15?
Yeah.
Yes, 15 is not a prime number. So the answer to the first question is yes, I can factor 15. Then you ask yourself, the next question is, are there perfect square factors of 15?
No.
No. So what am I supposed to do when it's factorable, but there's no perfect square factor? Leave it as it is. So if I have the square root of 15, square root of negative 15, we know that this is going to be I times the square root of 15. Remember, anytime you have a negative sign, you're going to have I. What are we supposed to do with that 15? Leave it alone. It's factorable, yes, but there's no perfect square factors.
Oh,
So that's the answer.
That's the answer.
Cool.
I see.
Wait, are you supposed to put the I?
Yes, because it's negative 15.
Okay.
You're changing negative 15 to positive 15, but you can't just do that.
Wait, but on this one, okay, because back to what I put like x squared equals negative 4,
Right?
and then like I changed it to positive.
But you can't just change it to positive.
I thought that's what you did.
The square root of negative 4 can be rewritten as the square root of negative 1 times the square root of positive 4.
So what do I do?
Did you write 2i?
Yeah.
2i means I is
Square root of negative
negative
1 is the I.
I is negative 1, so 2i is the same thing as negative.
Alright, number 2, please be careful. Use that chart. I promise, it's helpful. Okay, are there any other questions about how to do this? Okay, the last thing I want to go over is using quadratic formula to solve quadratic equations. The only difference between using the quadratic formula before the break and using the quadratic formula now is before, when we got down to this point, and we did 9 minus 40, which is negative 31, we would say that there's no real solutions, which is true. There are no real solutions, but now we've added in that extra component of imaginary solutions. So now we can keep going. So up until step number 3 here, it's exactly the same as when we used the quadratic formula before. We identified A, B, and C. We plugged them into the quadratic formula, and we simplified. The only difference is now we keep going until we're finished. So over here, you can see the arrow. I subtract 40 from 9, I get negative 31. The rest of my problem stays the same. I then convert the square root of 31 into I times the square root of positive 31. So here I have the square root of negative 31. I change that. Remember, the square root of negative 31 is the square root of negative 1 times the square root of positive 31. Negative square root of negative 31 is I. Can I factor 31? Are there any numbers that divide evenly? Only ice cream flavors. No numbers, only ice cream flavors. So I'm going to leave my square root of 31 alone. Like I did yesterday, I take my denominator and I attach it to each part of my numerator. So here's the first part, here's my A plus, there's my B, the square root of 31 over 4, and then I, that's a little I there. So A plus B, I. So my answer is in complex number form. Over here, down at the bottom, my number is not in complex number form. So you can't stop here. You've got to keep going to put it into complex number form. Okay?